if you take basically, cancer means what, you know, people? What do you mean by cancer? In our body, some cells are not active. Understanding? Some cells are inactive. Means they are not doing their function properly. That is only ways to called as cancer. I understand what I'm saying, Maitriyan, Laksha? So in our body, because of some problem, if any place, any part of our body, cells which are present, they become inactive and they will die. And there is no regrowth of cells, and there is no again continuity of their life, then that stage only we used to call as cancer, we used to say. So now for this cancer, what we'll do, we'll go with a treatment called as radiotherapy. In this radiotherapy, what they will do, they will send a isotope called as cobalt 60, understanding, inside our body. And what they will do, it will go inside, and this cobalt 60 isotope, it will produce a high gamma radiations. What it will produce, guys? High gamma radiations it will produce. So these high gamma radiations, they will go and they will blast. They will blast this tumor where it is present inside the body, and it will collect these cancerous cells, get collected, and they will start burned by it, and they will be bring it outside. So that is what we used to call as radiotherapy. Understand? So that is the third importance of radioactive isotopes or radioisotopes, we can say. So what is the first one? Nuclear power plant for generating electricity. Second one, to detect the traces of tumors and as well as blood clotting inside our body, and as well as for the treatment of cancer, we can use it. Next one, what is the fourth importance of this radioactive one? Is a biology common disease which is used to come in our below our throat. What is that, guys? Anybody can say?
Thyroid.
Thyroid.
Very good, Sai. Thyroid is the most common one which you used to see in so many. Even Tamil Nadu, thyroid is the most common disease. Most of the ladies is having thyroid. I used to notice it in hospital while we used to visit. So everybody is having thyroid problem there, say. So this radioactive isotopes we can use to determine the activity of thyroid gland, which will help in the treatment of diseases like, what is the disease getting by thyroid? Thyroid disease, what was the disease we used to got for thyroid?
Cancer.
Cancer, not. The disease name called as goiter. You may be heard called as simple goiter.
Yes, sir, iodine deficiency.
Yes, iodine deficiency leads to the simple goiter. Means our that throat will start swelling outside. That neck. Yes or no, guys?
Yes, sir.
That is what you have to understand. So this radioactive isotopes we are used to determine the activity of thyroid gland, which will help in the treatment of diseases like goiters. That is the fourth importance. Understand, Jayvarsini, Manya and Samaya, Laksha, everybody? So very, very important one. So that is, so which one we are using? So you might be heard, Prados only said, goiter is lacking of what? Because of iodine deficiency.
Iodine.
So we are using here to trace us, understanding, we are using iodine 131 isotope as a tracer to find how and at what rate the thyroid gland in our body takes up iodine and how much it is essential for making thyroxine hormone. What is the hormone released by thyroid gland? Thyroxine only. Yes or no? And it will help in the treatment of diseases like goiter. That is what we are using. So here, which isotope we are using? Iodine 131. That is what you have to remember. So the fourth importance is iodine 131 isotope, which we are using to trace the functioning of thyroid gland and what rate it is making the iodine, which will helpful for releasing the hormone called as thyroxine hormone. That is what it is, the fourth importance. Shall we go to the next important? So the last important, if you notice it, so you might be notice it, all of you. So suppose if you go to the Chennai, water supply line will be very, very deep inside the ground, and it is very, very long distance. Is it yes or no? Will you able to accept it? Yes,
sir.
Now suddenly you might be see some place water is leaking, or maybe the water may not reach us to that, so that we cannot dig completely. Is it yes or no? Again, we cannot dig the completely to check where it is leaking. Yes, guys, please respond. In this pipe, In this picture, you might be see a person is moving, walking on the surface of the ground. Inside the pipeline is there, and somewhere here they have been written a word called as, what is that word?
Leak.
Leak. So, radioactive isotopes we are using in the industries, understanding, to detect the leakage in underground oil pipelines. You might be see gas pipelines, oil pipelines, and all. Nowadays, we are going very deep inside the earth. Yes or no? For the safety line. So,
Yes, sir.
these gas pipelines and water pipes, etc., oil pipes, very dangerous, even country to country. Now, for example, if we take today's news, America and what is that country? There, Canada somewhere. That border issues is going on. Yes or no? So, there, Israel and America and Russia, war is going to start. You might be watching news also. Yes. So,
Ukraine
the
and
main
Russia.
reason. Sai, yes, Sai.
Ukraine and Russia, sir.
Ukraine and Russia, not Israel, sorry. So usually Russia wants to import oil gas lines and all, oil pipelines and all. They're having a very big pipeline through Ukraine only. So that is one of the major reason also. Ukraine is always threatened Russia that we'll stop the oil pipelines, not to supply the oil from the other countries and all. So that is why these many days Russia is also just waiting for the Ukraine to get a chance. But now they have made under the ocean, they have been constructed a pipeline to supply the gas lines and all. So now that is why even America is supporting Ukraine, and they're going to, I think they're going to soon going to hit a big war. We cannot predict it also, because they are making the troops to get ready for war. So now it is very difficult to detect leakage where it is happening in particular, because very deep inside, and that is also very dangerous. Oil pipelines and all very dangerous, correct? Gas pipelines inside. So it may causes even villages will burn if that leakage will takes place in industries and all, because that gases are very, very dangerous. So these metal pipelines and all, where the cracks are coming, and to check the leakage in a metal pipeline, a solution of radioactive substance is introduced in the pipelines. So at the place, the crack in the pipeline, the radioactive solution will leak out, and the radioactive detector, what is the detector called as, guide? What is the detector called as? Geyser
Counter.
Geiger
counter. Then it will indicate a high level of radiations, so that we can easily will find the crack or breakage or leak of any kind of pipeline. So what they will do, they will send the gas inside this. Are you understanding? So the radioactive gas lines, they will send inside. So wherever the damage is there, wherever the cracks of the pipes will appear, so it will be high radiations will be leaked there, and it will be detected by the George counter, so that we can say here the leakage exactly, so we can easily rectify that mistake. Is it yes or no? We can easily go with the replacement, or we can do a repair of these underground pipelines. So this is what the very important usage of isotopes. So the radioactive isotopes are used in the every industries, water industries, oil industries, gas industries, to detect the leakage in underground pipelines. Okay, guys. So that is what you have to remember it. So they will send these solutions inside the pipes. So wherever it is, we are leak out. That is what the damage or anything is takes damage, or any hole or takes place to the pipeline. So there they will go with the reconstruction or remodeling or the redesigning of that pipe with the proper safety measurements, because it is very dangerous. So these are the 5 importance of radioactive isotopes. Is it okay, guys? Radioisotopes are radioactive isotopes. So radioactive isotopes means what? Usually they are very dangerous to the human beings, but if you use very carefully by taking suitable precautions at a proper concentration, then we're having a lot of applications of radioactive isotopes. That these are the 5 examples of importance of radioactive isotopes. In that, the most dangerous one and the most important one for this 21st century is uranium-235. So uranium-235, we are using in nuclear power plants for generating electricity, but we can use them in manufacturing our nuclear weapons like nuclear bombs and nuclear atoms, nuclear weapons. That is why you might be see UNO, that I care. What is that? United.
United Nations.
Yes, UNOs. So you can see United National Organizations. It is bad. It is like we have to be some rules, restrictions are there. No country should test the this unbomb or nuclear bomb experiments. But you might be see Uttar Korea, South Korea. We can say sorry. Yeah, North Korea. They're always that Kim Jong Un. You might be heard. Have you heard Kim Jong Un?
Yes, sir.
Yeah, he's
Yes, sir.
always used to test and he used to invest most of money for this nuclear weapons only. That is why Uttar Korea, lot of restrictions from every country. They will never allow, and there are lot of restrictions on business and exports and imports and all. They will charge them because they will never follow the guidelines given by the UNO and all. But according to the UNO, no country should test any kind of nuclear bombs and all because after World War II, you might be so know the story of Hiroshima and Nagasaki. Yeah, it is causes extremely dangerous to the human surveillance. That is why it has been restricted, and with that promises only every country used to work. They can make the nuclear bombs and weapons, but not for testing because it may testing also leads to damage of large amount of area. That is why we people are not allowed to do any kind of nuclear weapons or bombs and etc etc. But lot of this all Talibans you might be heard terrorist troops. Yes or no? This all the
Yes, sir.
terrorist groups, they all is used to invest crores of money to buying of uranium 235. That is why you can see our like countries, people are this mafias and all, they will do illegal mining and they will export this uranium to the foreign countries and they will make crores of money by selling even 1 gram, half gram. What I'm saying, imagine two uranium 235 will hit each other like nuclear fission will take place. It will produce megawatts of electrical energy. Then imagine if you'll get 1 gram of uranium, how many atoms will be there? Avogadro number of atoms will be there in 1 mole of uranium. Yes or no?
Yes, sir.
Yeah, then if you are getting 1 mole of uranium, then imagine the situation. We can destroy like our Indian like 15 countries we can destroy with the help of one mole of uranium, like equals to the Indian 15 countries of India size. That much dangerous it is. At a time, very very extremely dangerous this uranium 235. But we are having very very important future nuclear electricity, nuclear energy only we are producing electricity because we are running out of all coals and all. Thermal energy and all going to destroy, going to extend soon. So we are going to depend on this nuclears only. But even see, our India also, Gujarat and all, some states are having nuclear power plants. But our South Indian states, we are not allowing because we know the effect of it. Even without electricity, we can survive. Yes, we are surviving millions of years before, but it may damage. Suppose, for example, see, Chennai only, Chennai, the beach it is. So near to that, they may be arranged one nuclear power plant, something goes wrong and it may blasted or explode, then complete Chennai will be destroyed by next day morning. Do you understand? No more Chennai. We will never even see footprints of Chennai also existed there. It's like one big city is existed before also we cannot find because that much extremely dangerous it is. That is why it is all the states are not interested to take nuclear power plants, even though central is ready to accept. Central is ready to give because that is only people are calling as development. If you are having a nuclear power plants, you are a developed country, they will say. If you go Japan, China and all, each and everywhere nuclear power plants will be there. That is why Japan, you might be see, every time it is hit with floods, tsunami and etc. etc. You may be see earthquakes and all. Have you noticed it? More every year earthquakes, floods and all used to come in Japan because of that is the reason. So these are the importance of isotopes. Which isotopes? Radioactive isotopes. So now we are going to study the next concept, that is very simple concept, that is what? Isobars. So now let us study what is meaning of isobars and what is the difference between isotopes and isobars. We'll study. So now isotopes means what, guys? We studied same atomic mass, different atomic number. Yes or no? Same atomic mass, different atomic mass. That is what we used to call as Isobars. Is it yes or no, guys? Please respond. So now what is happening? Next one, we are going to having isotopes over. Now, if it comes to the isobars means, remember, different atomic number. Atomic number is different, but who is same? Atomic
Mass.
same. So mass number is same. Mass number is same, but who is not same? Atomic number is not same. So like this one is to called as isobars. Isotopes means what? Same atomic number, different mass number. But here different atomic number and same mass number is called as isobars. Understood, Laksha, Manya and Samya? So that is only ways to called as isobars. Examples anybody can say. For example, if you take isobars, argon 1840. Argon, if you take first example, argon. What is the symbol of argon? Everybody?
AR.
Yeah.
Yeah.
1840.
Number 8.
Number of protons, number of neutrons, and number of electrons. Number of protons are how many? 18. Number of neutrons also 18. Number of protons how many, guys? Number of neutrons 22. Please respond.
Yes,
Number of neutrons are 22. Now what is the mass number? Everybody, what is the mass number of argon? What is
40.
mass number or atomic number? Mass number is equals to what? Atomic number A is equals to number of protons plus number of neutrons, which is equals to what? 18 plus 20 equals to 40. Yes, sir? This is the first one. Now let us take second one, that is calcium 2040. Calcium 2040. So what is the calcium 2040 means? Number of protons, number of, tell me. Number of protons how many? 20.
20.
Number of neutrons also 20. Number of electrons also 20. Now what is the mass number? Everybody? Mass number of calcium.
40.
Mass number is equals to, we can take number of protons plus number of neutrons, which is equals to what?
20 plus 20.
Which is equals to 40. So that we can say, you might be see, we can say argon 1840 and calcium 2040. Both are what, guys? Both are what?
Isobars.
Ways to call
Isobars.
isobars. Is it okay, everyone? Jayvarshini, Laksha, Manya,
Yes.
Samya, Alana, everyone. That is what you have to remember. So 1840 and 2040. Here who is changing? Atomic number is different. Understand? So this atomic number is 18. This atomic number is 20. But this mass number is 40. And this mass number is also what? 40 only.
40.
Yes or no? That is the first thing. That is what you have to understand. So if we take same number of atoms, same mass number, but different atomic number, we used to call as isobars. So now one more example let me take. Sodium and magnesium. So let me take sodium. If we take sodium, one isotope is what? Sodium 24 is also there. Sodium 1124 and magnesium. If we take magnesium 1224, if we take, so now here you can notice it. So atomic number is same. Z is equals to 11 and Z is equals to 12. What is the mass number? Mass number is 24. Here mass number is equals to 24. So this two I can say what? They are
Isobars.
Same mass number, different atomic number. That is what you have to remember it. Okay. But isotopes means what? Different atomic mass and same atomic
number.
That is what you have to remember it. So this is all we used to call as, what we used to say? Isobars. So if you take lot of isobars, for example, if you take, let me take uranium only, or else you can take any other elements which is having. So for example, uranium, if you take uranium 9231 and uranium 9233. So usually which is the famous uranium? I said uranium 232. Yes or no? 232, correct? So that is, so
235.
yeah, 230.
235.
Uranium 235. So if we'll take lot of things, we are having a same atomic mass, even they're having different atomic number. So this all we used to called as what? We used to called as isobars. Understand? So that is what meaning of isobars. So please all of you write isobars. Isobars are the atomic. Isobars are the atoms. Isobars are the atoms. Isobars are the atoms of different. Isobars are the atoms of different elements having different atomic numbers. But who is same, Alana? Who is same? Different atomic numbers, but same mass number.
Mass number.
Also called as what? Mass number also
Isobars.
atomic mass. That is same mass number. Having different atomic numbers, but the same mass number. Isobars are the atoms of different elements having different atomic numbers, but the same mass number. Is it okay? Darun, understand Tamil Selvan? That is. So we can say what? If we'll add number of neutrons plus protons, both equals to same. That is what we used to say. So examples, you can write two examples. What is that? Argon 1840 and calcium 2040. Both are isobars. Same way, if we'll take sodium 11 to 24 and sodium 1124 and magnesium 1224, both are same isotopes because they are having, irrespective of number of protons and neutrons, if you add sum, both atomic mass is same or mass number is same, but atomic number is varies. So this is what we used to call as isobars. Is it okay, guys? Everybody? So this is
Yes,
the
sir.
last concept in this chapter. So you understand, then you remember in this main important one, which will helpful in our future, is radioactive isotopes and their importance. So radioactive isotopes means what? The isotopes which will releases the energies like alpha, beta and gamma rays. That is what we used to call as radioactive isotopes. Also we can call as what? Radioisotopes. Directly we can say. So this is all about it. Then tomorrow we'll discuss exercise sums and any other extra sums and all, we'll discuss it. And with this, I will leave the today's class. Thank you, everybody. Bye. We'll meet tomorrow. Have you
Thank you,
Thank you, sir.
Have you
Thank
understood?
you, sir.
Yes, Javarshini, are you clear?
Yes, sir.
Okay, Javarshini. Thank you.